Right, children, let us start. Others are probably sleeping. This is the second assignment of first chapter. First numerical. Calculate molecular weight of compound, 0.2 mole of which weighs 75 grams. Either we'll use the formula. I told you 4 formulas. Either we'll use one of those formulas, or molecular weight is nothing but weight of 1 mole of the substance, right? Since 0.2 mole weighs 75 grams, so 1 mole weighs how much? That will be your answer, right? Otherwise, if you want to use those formulas which I told you last time, then it is calculate molecular weight of the compound. So this will be weight divided by molecular weight, because compound will always have molecular weight, not the atomic weight. 0.2 mole of which weighs 75 grams is equal to number of moles is given. So this is 0.2, weight is 75 divided by molecular weight. You can calculate, this will be the answer. Second, calculate the number of oxygen molecules in 1.12 liters of the gas at STP. See, we are given volume of the gas. So volume in liters divided by 22.4, this is number of moles. And we have to calculate number of oxygen molecules. So number of molecules will be number divided by Avogadro's number. So we have equated two parts. This we have to calculate. So number of molecules will be volume. Volume is 1.12 liters into Avogadro's number 6.022 into 10^23 divided by this is 22.4. This will be your answer. Anand, we are doing second assignment of the first chapter.
Okay, sir.
Third numerical. Calculate the number of oxygen atoms in 440 AMU of CO2. Molecular weight of CO2 is, wait a minute. Molecular weight of carbon dioxide is 44. It means number of molecules will be 440 AMU. AMU divided by molecular weight will be number of molecules. So these are 10 molecules of oxygen, and one molecule of oxygen contains 2 oxygen atoms. Therefore, number of oxygen atoms will be 10 into 2, that is 20. These are very, very simple numericals. The only thing is you have to get used to mole. Otherwise, mole will trouble you in entire chemistry. Next, fourth numerical. Calculate atomic weight of the element 44.64 grams, milligrams of which contains so many atoms. Now we are given number of atoms. So number divided by Avogadro's number is equal to weight divided by atomic weight. Now let us see. Calculate atomic weight. This we have to calculate. So atomic weight of the element will be weight. Weight is 44.64. This weight is given in milligrams. I have converted it to grams divided by 1000. So weight into Avogadro's number. Avogadro's number 6.022 into 10^23 divided by given number. Given number of atoms is 4.8 into 10^20. To calculate, you'll get the answer. Next, numerical number 5. An element exists in the form of triatomic molecules, like oxygen exists as O3, right? Let us say the element is X and it exists in the form of X3 molecules. This is the meaning of triatomic. If one atom of it weighs so many kilograms, calculate its atomic weight and molecular weight. Now we are given one atom number. So number divided by Avogadro's number is equal to weight divided by, we are given the weight of atom, therefore divided by atomic weight, right? Not molecular weight, because we are given the weight of atom. Now, atomic weight will be weight, this is 2.657 into 10 to the power minus 26. This weight is given in kilograms. We have to use the mass in grams. Therefore, into 10 to the power 3 multiplied by Avogadro's number, 6.022 into 10 to the power 23 divided by number. We are given one atom of element. So this will be atomic weight. Atomic weight will come out to 16. That is one answer. Therefore, molecular weight of X3 will be 16 into 3. That is 48. Next, numerical number 6. Calculate the volume occupied by 3.38 into 10 to the power 20 molecules of water at a temperature when its density is 1.01 gram per cc. First, we'll calculate the weight of so many molecules of water and then apply density is equal to mass per volume. Now, we are given volume occupied, calculate the volume occupied, and we are given so many molecules. So, number divided by Avogadro's number. Calculate the volume occupied by so many molecules of water at a temperature. Yes, we'll have to first calculate the weight of so many molecules. So number divided by Avogadro's number, and we are given weight. We have to calculate. Molecular weight of water is 18. So we'll calculate the weight. Weight of given number of molecules will be number, that is 3.38 into 10 to the power 20 into 18 divided by Avogadro's number. When we calculate, this will come out to 0.0101 gram. So weight of given number of molecules is this much. Now density is equal to mass per volume. Volume will be mass, that is 0.0101 divided by density. Density is 1.01. So many cc will be the answer. Cc is milliliter, right? That will be the answer. Next numerical, 7th. 1 liter of a gas weighs 2.5 grams at STP. Calculate its vapor density. If you remember, last time I told you molecular weight is equal to 2 into vapor density. So first we'll calculate molecular weight. We are given volume divided by 22.4 is equal to, we're talking about some gas, it will have a molecular weight. So this will be weight divided by molecular weight. Molecular weight will be weight 2.5 grams into 22.4 divided by volume. Volume is 1 liter. This will come out to 56. So molecular weight is 56. Then vapor density. See, molecular weight is equal to 2 into vapor density. Vapor density will be molecular weight divided by 2. 28 is the answer. 8th numerical. Chlorophyll contains 2.68% magnesium by mass. Calculate the number of magnesium atoms in 10.41 grams of it. We'll first calculate the mass of weight of magnesium present in the given amount of chlorophyll. It contains 2.68% magnesium. So 2.68% of 10.41. When you calculate, this will come out to 0.279 gram. So 10.41 grams of chlorophyll contains so many grams of magnesium. Now, we have to calculate number of magnesium atoms. So number divided by Avogadro's number is equal to weight divided by atomic weight of magnesium, that is 24. This will be the answer. So number of atoms will be 0.273 into value of Avogadro's number divided by 24. You'll get number of atoms. Next, this ninth numerical. Calculate the rate of sugar, molecular weight is 342, rate of sugar per mole if it costs rupees 20 per kilogram. See, we can use unitary method. It costs rupees 20 per kilogram. It means 1000 grams costs rupees 20. 1 mole means 342 grams. So 342 grams costs how much? That will be your answer. So 20 divided by 1000 divided and multiplied by 342 unitary method. As I told you last time, please do not expect such simple numericals in the exam. It is just the beginning. It is just the beginning. In this chapter itself, you'll come across many difficult topics and difficult questions. Next, 10th. Calculate the number of molecules in 9 drops of water if 20 drops of it weigh 1 gram. Weight of 1 drop will be, we are given 20 drops weigh 1 gram, and we are 20 drops weigh 1 gram, and 1 drop contains 9 in 9 drops of water if 20 drops weigh 1 gram. So 20 drops will be 1 gram, and 9 drops will be 1 divided by 20 into 9. So basically we have so much of water. Now we'll use mole concept. We have to calculate number of molecules divided by Avogadro's number is equal to weight divided by molecular weight of water. So this number of molecules will be weight is 9 by 20 multiplied by Avogadro's number. I'm writing Na, you know what is the value, divided by molecular weight of water is 18. Substitute, multiply, divide, and you'll get the answer. Last numerical. 13.4 grams of sodium sulfate X water, X is water crystallization, contains 6.3 grams of water crystallization. Calculate number of molecules of water crystallization in 1 molecule of the compound. Number of moles of water, 6.3 divided by 6.3 is water. So divided by molecular weight, so this will be 0.35 mole. Number of moles of Na2SO4. This is without water, only Na2SO4. That's why I've written dry. Total weight is 13.4 minus water 6.3 divided by molecular weight of this is 142. So when you divide, this will come out to 0.05. It means 0.05 mole of Na2SO4 contains 0.35 mole of water. 1 mole contains how much? That will be your answer. So 0.05 mole Na2SO4 has water is equal to 0.35 mole. 1 mole has how much? Calculate karoge to this will come out to 7. It means formula of the compound is Na2SO4 dot 7 water. So value of X will be 7. Now coming to theoretical questions. First one is, why do atomic weights of most of the elements have fractional values? This I taught you, this there in your notes also. Because average atomic weight is the atomic weight of an element is the average of atomic masses of all the isotopes in the proportion in which they exist in nature. This language is there in your notes also. I'll repeat. Atomic weight of an element is the average of atomic weights of all isotopes of the element in the proportion in which they exist in nature. So that's why values are fractional. If you remember, I gave you the example of chlorine. Second, what are two steps involved in distillation? In distillation, two steps are: number one, evaporation, and second step is condensation. Third, taking the example of H2, explain the difference between mass of one molecule and 1 gram molecule. Mass of one molecule will be 2 grams divided by Avogadro's number. Molecular weight is 2, so 2 divided by Avogadro's number, whatever comes out to so many gram is the mass of one molecule of oxygen. And the second is 1 gram molecule. 1 gram molecule of hydrogen is 1 mole of hydrogen, and 1 mole of hydrogen will weigh 2 grams. So there's a lot of difference. Fourth, what can be inferred from 1 mole of oxygen gas? It means one conclusion can be drawn if we say there's 1 mole of oxygen gas. Number one, we can say 32 grams of oxygen. Number two, we can say 1 mole is 22.4 liters of oxygen at STP. Third, we can say 1 mole of oxygen contains Avogadro number of molecules. These are 3 points which we can infer. These are the conclusion which we can draw. So that's all about the assignment. Now we proceed further with the syllabus. Next topic.